properties of logarithm. If x, y, and b are positive real numbers, where b is not equal to 1, and x is any real numbers, then the following holds true. So here we have special property. We have log of b to the power of r. If the base of the logarithm, the base of the exponential is the same, we said that is equal to just this exponent, r. And that should make sense because we have b to the power of r is equal to b to the power of r. Or also we have b to the power of a log of r with the same base b, also that would be equal to r. That's the one property that we're going to use, where r is greater than 0. Product rule, when I have log of x times y, we can expand it to log of x plus log of y with the same base b. Quotient rule is log of x over y. We're going to subtract this. We're going to expand it as log of x minus log of y with the same base b. Power rule would be log of x to the power of r. It would be r log of x with the base b. We want to use the properties of logarithm to rewrite each expression if possible, assuming all variables represent positive real number. We want to look at log of 36 m to the power of 5 with the base 6. So it looks like that I can use the product rule to expand this. If I have log of x times y with the base b, I can expand this to log of x plus log of y with the same base b. So in this case, I can write this as log of 36 plus log of m to the power of 5. Okay. Now, if I can make the base equal each other, according to this property that we learned, the base of the logarithm come up the same as base of the exponents. Whatever this exponents would be, that would be my result. And that should make sense also because we said b to the power of r is equal to this, that's b to the power of r. And don't forget that if I have log of x is equal to y with the base b, I can always convert this into its exponential form. B to the power of y is equal to x. So in this case, I have log of 36. I can write 36 as a factor of 6. 36 is the same as 6 to the power of 2. So in this case, I have log of 36 with the base 6. See, I'm looking at this base here, 6. That's why I want to make everything the base 6 where it's possible. I'm going to write this as log of 6 to the power of 2. Now the base is the same. I matched the base, so this whole thing must be equal to 2. So that's why log of 36 is the same as 2. With this one, you can use a power rule. Remember the power rule? If I have log of x to the power of n, I can move the n right front of the log. So it would be n log of x. We're going to keep the base the same as each other. Here would be called b. So in this case, I can move this 5 right front of log of m. So it would be 5 log of m with the same base 6. Use the properties of logarithm to rewrite each expression if possible. Assume all variables represent positive real numbers. Here we want to find log of square root of 9z. When you see a square root or cube root, the first thing you do is to use the fact that the nth root of a to the power of m is equal to a to the power of m over n. We want to write this as an exponential form so we can use a power rule. So in this case, square root of 9z is the same as 9z to the power of 1/2, because the exponents here is 1, this whole thing is to the power of 1, and this is the second root. So we're going to write 9, square root of 9z as 9z to the power of 1/2. Now I'm going to use the power rule. If I have log of x to the power of r, I can move the r right front of the log, and that would be the same base b. So in this case, I can move this 1/2 now right front of the log, so it would be 1/2 log of 9z. We're going to look at this. If it's a product, quotient, or power of something, it means we can expand them. Here it looks like there's a product, 9z. So if I have log of x, y, I can write it as log of x plus log of y with the same base b. Base would be the same for all of them. So in this case, you get log of 9z would be log of 9 plus log of z. This 1/2 belongs to both of them, so I'm going to write a parenthesis here. We have 1/2 log of 9 plus log of z. Now if I can make the base of this logarithm the same as base of this exponential, then I can reduce them. Looks like 9 can be written as 3 square, right? 9 is 3 square, but however it doesn't matches the base, but I can use a power rule to move that exponent. So if I write 9 as 3 square, I can move this 2 right front of this log. So that would be 2 log of 3. The best I can do here for that one. So therefore I can go ahead and distribute 1/2 times 2 log of 3. 1/2 and 1/2 reduces to 1. So we get log of 3 here plus 1/3 log of z. 1/2 times log of z. Notice that the base is the same as 2 for both of them. So this is how I can rewrite this logarithm. Use the properties of logarithm to rewrite each expression if possible. Assume all variables represent positive real numbers. Looks like I can use the quotient rule here. If I have log of x over y, I can write this as log of x minus log of y to rewrite this. The base would be the same. So in this case, we want to find log of 8r squared over m minus 1 when m is positive and b is not equal to 1. So I can write this as log of 8r squared minus log of m minus 1. I can expand them this way. Here I have a product. So every time you have a product, quotient, or power, you can expand them more. So in this case, if I have log of x times y, that would be the same as log of x plus log of y. So it looks like I have that here. This is my x, this is my y. I write it as log of 8 plus log of r squared. Here I cannot do much with this. This is not a product, quotient, or power or anything. It's just a difference. So we just leave it alone. But over here I can use the power rule. If I have log of r to the power of 2, I can move the 2 right front of the log, right, as 2 log of r, and the base would be the same for both of them. So there we have it, 2 log of r. So we expanded this to log of 8 plus 2 log of r minus log of m minus 1. If you look at these, make sure these are not a product, quotient, or power of some numbers. This is not, this is not, this is not, this is a difference, so we don't have any property here for that. As long as it's not product, quotient or power of something, it means you're done. We cannot expand them anymore. Use the properties of logarithm to rewrite each expression if possible. Assume all variables represent positive real number. Here we have 2 log of x plus 3 log of y. B cannot be equal to 1. Same base b for both of them. So here we want to write this as a single logarithm. First, I can use the power rule to move this 2 right up here. So I can write it as log of x squared. We call that, if I have log of x to the power of r, I can write it as r log of x, same base b for both of them. That's what we're doing here. We're doing this backward. We're moving this 2 right on top of x. We're moving this 3 right on top of for exponents y. So now I can combine these using the product rule. If I have log of x times y, you know that's the same as log of x plus log of y. Notice the base is the same for all of them. So here, if I have a sum, I can change it to the single logarithm. That's what we're doing. Here we have a sum. We write it as a single logarithm. It would be log of x squared times y squared. So we're writing it as a single logarithm. Use the properties of logarithm to rewrite each expression if possible. Assume all variables represent positive real number. Here we have log of 3x plus y. Let's take a look at all the properties that we learned so far. We said if I have a product here, x times y, I can expand this to log of x plus log of y. If I have a quotient, x over y, I can expand this. I can write this as log of x minus log of y. If I have a power, x to the power of r, I can expand this as r log of x. These are the 3 that we learned. If it's a product, quotient, and the power. You notice I didn't write the base to not make this really crowded. If there's no base there, it means assume it's 10. But if it is not 10, you have to mention what it is. So you can write a B here to just indicate that this could be any base as long as it's the same base for all of them. You write the base right below this log. That's how you write them. Okay, so in this case, you notice that 3x plus y is not a product of anything. It's not a quotient of anything. It's not a power of anything. So here it cannot be, you cannot write this as any expanded form. It cannot be rewritten.